Good morning, students. Exercise 6.3, third problem. Prove that the box product of A vector minus B vector, B vector minus C vector, C vector minus A vector is equal to 0. You consider the box product. Here you are having three vectors. They are given within the box product. So box product is nothing but the scalar triple product. So I'll take the cross product of first two vectors, then dot product with the third vector. So it is written as A vector minus B vector cross B vector minus C vector dot C vector minus A vector. So look at the first two terms. Okay, in between what you are having? Cross product. So here you are having minus. So what you can do? You can distribute the cross product. So it will be A vector cross B vector. First vector A vector cross B vector. Next one A vector cross minus C vector. So the minus we can take it out. So minus of A vector cross C vector. Next you come to the second vector, take minus B vector. And minus B vector cross B vector, that is minus of B vector cross B vector. Then minus B vector cross minus C vector. So minus into minus plus. So B vector cross C vector dot C vector minus A vector. So in the cross product of two equal vectors, that is B vector cross B vector, it is 0. So that only we have written in this step. Next you consider you are having A vector cross B vector minus A vector cross C vector plus B vector cross C vector dot C vector minus A vector. So take this first vector and take the dot product with the C vector. So it will be A vector cross B vector dot C vector. The same thing you just take the dot product with the second vector. So it is written as A cross B dot minus A vector. So the minus can be taken out. So minus of A vector cross B vector dot A vector. Next one, the same way you take this vector and take the dot product with C vector and minus A vector. So it will become minus of A vector cross C vector dot C vector. Okay, so here also you are having minus, here also you are having minus. So minus into minus will become plus here. Plus A cross C dot A vector. The same way you take this vector and take the dot product with C vector and minus A vector. So it will become B vector cross C vector dot C vector minus B vector cross C vector dot A vector. So in this step you should not use the box product, because box product having the meaning, so it is nothing but the scalar triple product. So if you want to remove the box product, you have to use the cross product between first two vector, then dot with the third vector. So up to this I have used only the parenthesis. You look at this now, this step, how it will be. So in between the two vectors you are having cross product, then outside you are having dot product with the third vector. So it is nothing but the scalar triple product. So here I am using the box product A vector, B vector, C vector. Here also the same thing. So the minus is here. So it is a box product of A vector, B vector, A vector. This also scalar triple product. So I am using the box product of A vector, C vector, C vector. Here also box product of A vector, C vector, A vector. This also in the box product of B vector, C vector, C vector. And the last one is minus box product of B vector, C vector, A vector. So in the box product, any two vectors are equal, the box product is equal to 0. Okay, about this box product is 0. Here also C vector are equal, so it is also 0. Here also 0. Here also 0. So you are getting the first vector and the last vectors, box product of vectors. So this is box product of A vector, B vector, C vector. So the box product, the vectors are in the cyclic order they are equal. So I have written B vector, C vector, A vector. They are in the cyclic order. So I am going to write this as box product of A vector, B vector, C vector. So if you subtract the same, you will get the answer as 0. So we have proved the result. In the same way, we can prove box product of A vector plus B vector plus C vector plus A vector is equal to 2 into box product of A vector, B vector, C vector. So here in between you are having plus, here you are having minus. So if you have minus in the box product, it is equal to 0. Here for this box product, if you in between if you are having plus, your answer is 2 into box product of A vector, B vector, C vector. So now we are coming to the fourth problem. If A vector, B vector, C vector, okay, 3 vectors are there, you have to verify that the first and the second result. This is the, you see that how many vectors it involves? 3 vectors. So here also you are having cross, here also you are having cross. So it is a vector triple product. So you have to verify vector triple product expansion. Okay. So first I am going to take the first subdivision. In the left hand side what we are having? A vector cross B vector cross C vector. So how to evaluate this? First you have to evaluate the vectors which are within the bracket. So I will consider A vector cross B vector. So cross, how to evaluate the cross product? It is nothing but the determinant I, J, K, and you have to write the components of A vector. So it is 2, 3, minus 1. Then the components of B vector 3, 5, 2. So if you expand by R1, you will get this answer. So next one, what you are getting? What you are having? A vector cross B vector cross C vector. So you take this as a single vector. So second vector is C vector. In between you are having a cross. So you have to use the determinant. First row I, J, K. Second row what has to be written? The components of A vector cross B vector. So 11 minus 7, 1. Then C vector. So C vector components is minus 1, minus 2, 3. So while you are evaluating, you will get this answer. Minus 19 I cap, minus 34 J cap, minus 29 K cap. So you mark this as 1 because we have completed the left hand side. Next we have to move to the right hand side. Right hand side first term is what? A vector dot C vector. You see that? First term is what? A vector dot C vector. You look at this. This is your A vector and here you are having the C vector. In between what you are having? Dot. So how to take the dot product? So you have to multiply the same components then add. So 2 into minus 1, that is minus 2. Plus 3 into minus 2, that is minus 6. Minus 1 into 3, minus 3. So your answer is minus 11. So what is the term here? A dot C into B vector. So A dot C is number, it's a minus 11 into B vector I have written. So it's a scalar multiplication. So minus 11 into 3, minus 33 I cap, minus 11 into 5, minus 55 J cap, minus 22 K cap. So first term I have completed. So in the same way you have to complete the what is that? Second term. So second term first is B vector dot C vector. So B vector and C vector is written. So in between dot product. So you have to multiply the same components. 3 into minus 1 is minus 3. Plus 5 into minus 2 is minus 10. Plus 2 into 3 is 6. So while you are calculating, the answer is minus 7. So next that number has to be multiplied with the A vector. So minus 7 into A vector. So you will get minus 14 I cap, minus 21 J cap, minus, so minus into minus plus 7 K cap. So what you have to do? The second term has to be subtracted from the first term. So this is the first term and this is the second term. Okay, minus 33 I cap plus 14 J cap. Why I am writing plus now? So it's a subtraction. You have to change the sign of the second term. So it will be minus 19 I cap. In the same way, minus 55 plus 21. So that is minus 34 J cap. So here minus 22 minus 7 k cap. So that is minus 29 k cap. You call this as 2. So come to compare with 1. So 1, what you are having? Minus 9 I cap minus 34 j cap minus 29 k cap. So from 1 and 2. So this vector triple product can be written as a vector dot c vector into b vector minus b vector dot c vector into a vector. In the same way, second subdivision, a vector cross b vector cross c vector. So in the left hand side you have to consider first what are the vectors involved in the bracket. So here b vector cross c vector. So it is b vector cross c vector has to be found first. It's a cross product. You have to use the determinant and find the value. Next, you have to consider the whole term a vector cross b vector cross c vector. A vector is a first vector, b vector cross c vector is a second vector. In between you are having cross. So again you have to evaluate using the determinant. First row ijk, second row you have to write the components of a vector. Then the third row you have to write the components of b vector cross c vector. What is it? 19 minus 11 minus 1. So when you expand by r1 you will get the answer. So left hand side is over. So you call it as 1. Next, in the same way, take the right hand side term. So this is the right hand side term. Go for the first term, that is here you are having a dot c. So already we have found a dot c. So it is minus 11. This minus 11 has to be multiplied with b. So you will get this answer. What is the second term here? It is a vector dot b vector. So you have to take the dot product between a vector and b vector. You will get the answer as 19. So this 19 number has to be multiplied with the c vector. You will get this. So this vector has to be subtracted from the first term vector. So minus 33 here plus 19 I cap is equal to minus 14 I cap. Minus 55 j cap plus 38 k j cap is equal to minus 17 j cap. Minus 22 k cap minus 57 k cap is equal to minus 79 k cap. You compare with 1 and 2. Both the results are same. So we have to conclude, what is it, from 1 and 2. So you call this as 2 from 1 and 2. First result and the second result, we have to conclude a vector cross b vector cross c vector, which is equal to a vector dot c vector into b vector minus a vector dot b vector into c vector. Okay, so fourth problem is over. Now you are coming to the seventh problem in the exercise 6.3. So here you are having a vector, b vector, c vector. 3 vectors are given and a vector cross b vector cross c vector. Vector triple product is equal to L a vector plus m b vector plus n c vector. If it's so, you have to find the values of L, m, n. Okay, so see now what is given. The vector triple product is equal to L a vector plus m b vector plus n c vector. Okay, so what is the expansion of this? So how to write the expansion of vector triple product? So the previous video I have said the formula, lambda into middle vector minus mu into non-middle vector. So which is your middle vector? Your b vector. So how to write lambda? So it is a dot product of the vectors other than middle vector. So it will become a vector dot c vector into b vector minus, next you have to write mu. What is mu? It's a dot product of the vectors other than non-middle vector. So a vector dot b vector into c vector. So that is equal to L a vector plus m b vector plus n c vector. It is given. So equating the components of a vector, b vector and c vector. So a dot c is a number. So one number into b vector minus another number into c vector. So which is equal to L a vector plus m b vector plus n c vector. So see that here the component in the right hand side, the components of a vector is L. Here no A vector is present. Okay, so L is equal to 0. Next, you see that B vector component, here what you are having, A vector dot C vector. So A vector dot C vector is equal to M. The same way C vector component is minus A vector dot B vector is equal to N. Okay, so now you consider this. You have to find the dot product between A and C. So A vector is this, C vector is here. So in between dot product, same components has to be multiplied. So 1 into 3, 3 plus 2 into 2, 4 plus 3 into 1 is 3. That is equal to M. So you are getting M is equal to 10. In the same way you consider this, minus of A dot B is equal to N. So this can be written as A dot B is equal to minus N. So A vector and B vector is given. In between you are having dot product. So same components has to be multiplied and then add. So your answer is 2 minus 2 plus 3, that is equal to minus N. So 3 is equal to minus N, N is equal to minus 3. So we have found the values of L, M and N. So come to the next problem, 8th problem. If A cap, B cap, C cap are 3 unit vectors such that B vector and C vector are non-parallel and A vector cross B vector cross C vector is equal to half B vector, B cap. Find the angle between A vector, A cap and C cap. Okay, so see what is given. A cap, B cap, C cap are unit vectors. So unit vectors means whose modulus is 1. So modulus of A cap is equal to modulus of B cap is equal to modulus of C cap is equal to 1. Also what is given? The vector triple product of 3 unit vectors is equal to half into B cap. So this is given. So you have to use the expansion of vector triple product. So A cap dot C cap into B vector minus A cap dot B cap into C cap is equal to half into B cap. The same way equating the components of the vectors on both the sides. Here only B cap is here. So what is your B cap component? It is A dot C. So A dot C is equal to, here the B cap component is half. So A cap dot C cap is equal to half. And come to the next C cap component. So here you are having in the left side minus A cap dot B cap. Here you are having 0. So you are getting A cap dot B cap is equal to 0. Come to this. Here you have to use the definition of dot product. What is the definition of dot product? Modulus of A cap, modulus of C cap and cos theta, where theta is the angle between A and C. That only we have to find. So it is equal to half. So modulus of A cap is what? They are unit vector, so whose modulus is 1. Here also C cap is also a unit vector whose modulus is 1. So cos theta is equal to 1 by 2. So now you are getting cos theta is equal to 1 by 2. So half can be written as cos of 60 degree only. It is half. So theta is equal to pi by 3. Okay, so theta is what? Angle between A cap and C cap. So angle between A cap and C cap is pi by 3, that is 60 degree. Okay, so next one, it is called Jacobi's identity. For any 3 vectors, A vector, B vector, C vector, we have A cross B cross C vectors plus B vector cross C vector cross A vector plus C vector cross A vector cross B vector is equal to 0 vector. That is the sum of the vector triple product which are in the cyclic order is equal to 0 vector. That is called the Jacobi's identities. So you have to use the expansion of vector triple product. You will get the result as 0 vector. Next we are moving to the Lagrange's identity. For any 4 vectors, A vector, B vector, C vector, D vector, we have A vector cross B vector dot C vector cross D vector is equal to determinant A dot C. A dot C. Next term A dot D. Second row first term B dot C, B dot D. So you see now how many vectors here you are having? 4 vectors. Okay. So when you take the cross product of first 2 vectors, you will get a vector. In the same way, the cross product of third and the fourth vector is also a vector. So in between what you are having? Dot. So dot product between the 2 vectors is a number. So it is called the scalar product of 4 vectors. That is the Lagrange's identity. We are getting the formula to find the scalar product of 4 vectors. So the formula is determinant A dot C, second term A dot D, come to the second row B dot C, B dot D. We'll see the proof now. So first, you see that this dot product and cross product are interchangeable. So here this can be written as A dot B vector cross C vector cross D vector. You can see the vectors which are within the bracket. So it is nothing but how many vectors are there? 3 vectors. So here also you are having cross, here also you are having cross. So it is a vector triple product. So you have to use the expansion. So for that you have to you have to find out the middle vector. So C vector is the middle vector and D vector is the non-middle vector. So first you have to write B vector dot D vector into C vector minus B vector dot C vector into D vector. Okay. So see now here you are having dot. This is also a number. So this can be written as A dot C vector into B dot D vector minus the same way A dot D vector into B dot C vector. Okay. So see that this can be written as, this term can be written as in the determinant. You look at the first term A dot C into B dot D. So A dot C if you written as a first term, B dot D should be in the last term. So then only while you are evaluating the determinant, you have to multiply these 2 terms. So it is A dot C. Here you are having B dot D. So come to the next term, it can be written here A dot D, B dot C. So if you evaluate this determinant, you have to multiply these 2 terms. So here you are having, in between you have to write minus. So minus, you have to multiply these 2 terms. So it is here. So this step can be written as determinant A dot C, A dot D, B dot C, B dot D. So this is the formula for evaluating scalar product of 4 vectors. Fifth problem, A vector, B vector, C vector. Then find the value of A vector cross B vector dot A vector cross C vector. So see that here how many vectors? 4 vectors. In between you are having dot. So using Lagrange's identity, how it will be written? It is a determinant A dot A, then A dot C, next row B dot A, B dot C. Okay, so you have to take the dot product of A vector dot A vector. So A vector dot A vector, now the same components has to be multiplied. 2 2s are 4, 3 3s are 9, minus 1 into minus 1 plus 1. Okay, A dot C, A vector and dot C vector. So these 2 vectors has to be multiplied using dot. So 2 into 1, 2, 3 into 1, 3, minus 1 into 1 is minus 1. So here what you are having? B dot A. So B dot A, you have to take the dot product between B and A. So minus 1 into 2 is minus 2. 2 into 3, that is 6. Minus 4 into minus 1 is plus 4. Here you are having B dot C. So minus 1 into 1, that is minus 1. 2 into 1 plus 2. Minus 4 into 1 is minus 4. So when you are calculating, the term is 14. Here you are having 4. Here 10 minus 2 is 8. Here minus 1 minus 4 is minus 5. Minus 5 plus 2 is minus 3. It's a determinant. How to evaluate? 14 into minus 3, that is minus 42. So here you have to write minus, then you have to multiply 8 into 4, that is 32. So your answer is minus 74. So next one, we are coming to the vector product of 4 vectors. So see that in Lagrange's identity, here you are having dot product. Now you are having cross. So how many vectors are there? 4 vectors. So it is called the vector product of 4 vectors. So you can write this as in 2 answers for the same question. So vector product of 4 vectors, you are having 2 answers. So you can write box product of A, B, D vector into C vector. It's a number. So number into C vector minus A, B, C box product into D vector. Okay, and the same question you are having one more answer. It's a box product of A vector, C vector, D vector into B vector minus B vector, C vector, D vector into A vector. So you see that the proof, first you have to take this A vector cross B vector as a P vector as a single vector. So this A cross B can be written as P vector. So now it is a vector triple product. You have to use the definition of vector triple product. Okay, so you will get this answer. So in that answer, you have to write P vector as A vector cross B vector. So you will get this. Okay, so look at this term. Cross product of first 2 vector, then dot product with the third vector. So it is nothing but scalar triple product. So it can be written within the box. So it is box product of A vector, B vector, D vector into C vector minus, this can be written as box product of A vector, B vector, C vector into D vector. So you will get the first formula. So now you are taking C vector cross D vector as Q vector, the second vector as a Q vector. So this term can be written as A cross B vector cross Q vector. Again use the definition of vector triple product. So this is a middle vector and this is a non-middle vector. Lambda into middle vector minus mu into non-middle vector. Now you have to substitute Q vector as C vector cross D vector. This also a scalar triple product. So it can be written as box product of A vector, C vector, D vector into B vector minus B vector, C vector, D vector into A vector. Okay, so you see how to remember this formula. So first, if you write the third vector is written out. Okay, third vector is written out. So the remaining 3 vectors should be written within the bracket. Okay, C vector oda combine ஆயிருக்க vector வந்து D vector. So next step, next term, you have to write the D vector outside. So if D vector is written out, what is remaining? A, B, C. That vector has to be written within the bracket. Okay, otherwise if you consider the first term, so B vector is written out first, the remaining vectors should be written within the bracket minus, so B vector oda which vector is combined? A vector. So next you have to write the A vector outside. What is remaining vectors? B vector, C vector, D vector. That has to be written within the box product. Okay, in this way you can remember this vector product of 4 vectors formula. Okay, so see now exercise 6.3, 6th problem. If A vector, B vector, C vector, D vector are coplanar vectors, you have to show that A vector cross B vector cross C vector cross D vector is equal to 0 vector. So what is given? The 4 vectors are coplanar vectors. So coplanar vectors means they lie in the same plane. All the 4 vectors lie in the same plane. Okay, so how is your A vector cross B vector? So if you take cross product between 2 vectors, that vector is perpendicular to A vector and B vector. But how is your A vector cross B vector? Is perpendicular to A vector and B vector. Next, how is your C vector cross D vector? It is, this vector is perpendicular to C vector and D vector. So that's why A vector cross B vector and C vector cross D vector, both the vectors are perpendicular vectors to the plane containing A vector, B vector, C vector and D vector. So how they should be? They are parallel because both are perpendicular to the plane having A vector, B vector, C vector. So therefore they are parallel. These two are parallel. Any two vectors are parallel, the cross product between them is equal to 0 vector. So we have proved the result. A cross B vector cross C vector cross D vector is equal to 0 vector. Thank you, students.